recording. So I was saying that the thing about lab 1 is that it's very descriptive, and when you have a descriptive lab where you have to describe and observe and try to explain things, sometimes you have open-ended questions, and this is confusing for students. Unlike other labs where you have to do calculations, it will be much easier and straightforward. All right. Okay, I'm assuming that you guys are gonna be fine. I just saw that Fadi is with us. Fadi, it seems that you did not submit your first lab. Do you have difficulties? Trying to speak to Fadi. Fadi, can you hear me? All right, I will come back to Fadi. Yes.
Professor, I have a question.
Say it again, Nazih, explain.
Professor, about the lab report, I sent it, right? Or...
Yeah, it shows that you did not submit yet. It shows that you uploaded though. Can you try to submit again?
Will I lose points if I didn't submit?
No, don't worry about points at all. This is the first week is a trial for everyone. So I'm here just to be your advisor and to push you submit on time. Don't worry about this. As long as you are on track, you know what you're doing. You submit on time, it will be good. Okay, so Nazih, try to fix this issue. Now back to you, Fadi. I know that you have a trouble with your microphone. Please try to fix this as soon as possible. Fadi, it shows that you did not submit your lab report. I assume you have problems. I need to help you fix those problems. So if I can be of any help, please come back to me and do not wait, neither ignore the fact that you had a deadline today at 5, okay? We have a new deadline coming up next Monday at 5. So that's why I want you to be ready for our deadline number 2. All right, Fadi, please type in the chat box if you have a problem or not. Waiting for Fadi to type. All right, while Fadi is typing in the chat, okay, all good. I assume, Fadi, you're gonna submit your work today. Email me if you have issues. I think we're ready for lab number 2. I just got us lab number 2, it's here. I can put away the list of participants and keep the chat maybe. All right, that's lab number 2. It's a very easy lab, it's about free fall. I can, yeah, no problem, Fadi, will get used to it. I can easily discuss few things with you, maybe insert some comments here and there. Yes, so I need people to describe for me what is a free fall. So please speak up if you know. What is a free fall? What is free fall?
Include the gravity and the mass. The gravity, okay. Acceleration, and the Wazn.
All right, so maybe let me change my question. If an object is in free fall, okay? What are the forces on the object? What are the forces on the object?
Can we say the gravitational force?
The gravitation.
Okay, the gravitational force. So let me go out of this one. So let's say I have this point-like object, and this is the ground. It's in free fall. The only force acting on it is the force of gravity. I'm gonna call it weight or force of gravity. Okay? Do you know how to calculate your own weight or your own force of gravity? Maybe ask Rima. Rima, if my mass is equal to 50 kilograms, or let me say 51 kilograms, what would be my weight? How do you calculate my weight?
Is it something m times a?
It's m times g.
G.
Okay. And you know the value of g?
9.8.
Yes, I'm gonna take it to be 9.8. By the way, g is the gravitational acceleration, and the unit of it is meter per second squared because it's an acceleration. Do you have a calculator next to you?
Yes.
Okay, what would be my weight then?
It would be
51.
499.8.
So 499.8. What would be the unit of my weight? Newtons, perfectly well. So you just said that the force of gravity applied on me is this. So let me say that the only force is the force of gravity that a lot of people would call the weight. Okay? Now, Newton's second law states, or if you want, the acceleration. Somebody just mentioned acceleration. During free fall, what is the acceleration? So during free fall, what is the acceleration of the object? Acceleration equals to how much?
It's equal to 9.8.
It's equal to 9.8 meter per second squared, which is g. Okay, so far all you need to know is during a free fall acceleration, during like when you're free falling, and by the way, you have to neglect air resistance. So let me highlight this. This is very important. G is equal to 9.8 meter per second squared, and that's your acceleration. All right, now I'm gonna show you the video of the experiment before I discuss the lab reports. Okay. Joseph, you're asking if you submitted the work. It says that Joseph, let me check. Joseph did not submit the work. And I was asking to talk to you a few minutes ago, but you were not with us. So yes, Joseph, if you have issues, let me know. So I'm gonna fetch the videos to show you free fall. Maybe watch it in a fast pace because you can watch it later. Okay, stay with me. I'm gonna show you the equipment needed. Let's introduce experiment 1, free fall. What you need. By the way, that was experiment 2. I made a mistake. Experiment 1 was description of motion. You need a picket fence, which is a transparent ruler on which you have black strips. The distance between the black strips is constant and given, so it's already in the setup of your activity. And the thickness of the strips is also constant and given. So equipment number 1 is the picket fence. And here you have the photo gate. So what is a photo gate? It's a user-friendly sensor. So you just have to connect the digital plug into one of the science workshop. And how does it function? It's basically, as you can see, you have a beam that is not visible, obviously, between the terminals of the photo gate. Every time you block the beam, the photo gate will register through Data Studio the time taken through which you've been blocking the beam. So it can tell the time. Knowing the thickness of my finger, you can tell the speed of my finger. So the speed is distance over time, or thickness, or distance covered through the beam divided by the time taken. So as you can see, all right, so basically this may sound complicated a little bit. I want to take this ruler that is called picket fence and make sure the ruler goes through the beam at a certain speed before I free fall it. The photo gate will actually measure the time taken by the ruler to go through the beam, so it can tell easily the velocity as a function of time, so you can find the acceleration. Okay, so let me see how it will go. Photo gate is very similar to the motion sensor, but used differently. So it will help me find the speed as a function of time, especially that you have many strips. So that's for the equipment needed. Now for the procedure, what you need to do, you need to take the picket fence strip or ruler and put it around 10 centimeters above your photo gate and release it. If I release it, it's gonna bump into the table. So I'm gonna find a way to put my photo gate in such a way to be like that, away from the table. And I'm gonna take the ruler again and throw it inside the photo gate beam as such. It's gonna bump into the floor, which is okay because the ruler is flexible and it's not gonna be broken. 1, 2, 3, go. All right, I need someone to explain to me. Now the ruler, did it undergo free fall, yes or no? And I'm sorry again if the photo gate was out of the picture, but you will see the experiment again where the photo gate is really clear. So Joseph, I will come back to you later. So back to you, you saw me releasing the photo gate and it was dropped to the floor. Do you believe this is free fall, yes or no?
Yes, It has the initial equal to 0.
All right, so releasing the ruler means V initial is 0. What are the forces on the photo gate?
Gravity.
Force of gravity. Anything else? Maybe air resistance. And hence, since I have air resistance, which is underlined in here, I cannot say this is free fall. So basically what I just did is something that I can assume or estimate to be a free fall, but it's not gonna be super free fall. Okay, so let's continue the video and see how I can register through Data Studio the different values I need to measure. So this is how you do the experiment. Let's see how we can take the measurements. How do you find the file or the activity that you need? You go onto the desktop, you go into the folder mechanics, and you fetch the activity freefall. This is freefall. You minimize your workbook, and this is what you will get. Okay? So as you can see, you have a table of measurements. Whenever you click start and you throw your picket fence, you will have a position time table, velocity timetable, and acceleration timetable. How do we do the first trial? I get ready with my picket fence very close to the edge of my desk. I get ready with my ruler on top of the picket fence, and I use the mouse ready on start. I click start, and then I release my picket fence. It's okay if it will go to the ground, it's not gonna break because it's very flexible. So I will release it for it to go. This is the first trial. You see some values in here. I'm gonna zoom in for you to see them. Let me click on stop. Yes, for the Data Studio to stop recording data. And let's come closer to the screen to see what values we've got. All right, so as you can see, I already did one trial, and the activity just gave me a position versus time, velocity versus time, acceleration versus time. I will get the camera closer so for you to be able to see what values you've got. So what do we see? You actually see that you have a position versus time. So you see as the time, and all this within a fraction of a second, between 11.45 seconds and 11.56. You see that the position is changing in a linear way since you have the positions of the strip, and you can see that the actual, the distance between the strip is a constant. The position should not be linear though due to the acceleration, but maybe through a very short time interval you cannot see it. You see that the velocity is increasing with time, and the acceleration sound fluctuating around a constant value, we don't know. So what you need from this table is only a list of time versus velocity. All right, and you have to write this down in your lab report. All right, I'm done with the video. Now let me continue through the lab report. Let's say fill in the table with velocity versus time data. This is what I should do. So as you can see, you have 3 trials. Yeah, all right. You only have 3 trials, trial 1, 2, and 3. So I'm gonna give you a lab report in which you will be given the different times and the different velocities, and I'm gonna do 3 trials for you, which is the same experiment repeated 3 times. Question number 1, plot the 3 graphs of velocity versus time using the data collected. Using linear regression, calculate the slope of the 3 graphs, okay? Do you think you guys can do that? Do you know how to plot? And do you know how to do linear regression to find the slope?
Excel.
Yes, we have an appendix for this session in which we're gonna do classwork and do the work required. Now find the average value of the different slopes. Like you found slope number 1, you found slope number 2, and you found slope number 3. The question is, these 3 slopes are basically acceleration 1, acceleration 2, and acceleration 3. Can you find the average? So how do you find the average of a certain value? And how do we find the error on the average that we usually call RMS? I suppose you know how to do that, so I'm not gonna help you with this. I will give you some time. If you believe you're not sure about this one, please go back to Data Studio to chapter 0 and watch the videos again. maybe the slides, and let me know if you still have difficulty on that level. Okay? Now for question 4, 5, and 6, these are something to sketch or something to discuss that you can do later on. Before I leave you, I would want us to take an example, maybe from the video. Is the video visible? Let me check. Where's the video? I just minimized the video or not. Okay, I can open it again. So the video for free fall, yes. I will move this, maybe take a screenshot and zoom in. I don't know if it will be visible. Wow, this is so small, but I'm gonna try anyway. Okay. All right, so I'm gonna open Excel and I'm gonna give you a very small assignment. And maybe ask Reem to be less. Okay, she's very loud. Can you hear her? The monkey inside. Okay, this is Excel again. I just came from the campus. So let me insert the document so we can keep it next to us. And I'm gonna give you a list of questions. Meanwhile, you can get ready with your Excel. All right? So this is it. All right, I know it's not visible. I'm gonna type it again. So the velocity is given as 1.65, 1.91, 2.12, 2.33, 2.53. Maybe include that in the list of results. Okay, so this is velocity being meter per second. Question number 1 that I'm gonna ask you, plot V versus time to find the slope. Okay, let me give you the time needed. Time is in seconds. It's gonna be 11.4356, 11.4638, yes, 11.4887, 11.5113. This is gonna be very difficult to plot on a graph paper, by the way, because it's very difficult for you to find an appropriate scale for those very small change in units. Okay, all right, let me make this a little bit bigger. Okay, so do you know how to proceed? We don't need this anymore. Let me remove it.
We have to do it on a paper?
No, do it now in front of you and tell me maybe, you can tell me privately on the chat your answer for the slope. Okay, I'm gonna do the work in front of everyone as well, but I'm gonna give everyone like 5 minutes of quiet time to be able to find the slope. So when you find the slope, you have to type it in the chat, but type it please privately for me.
Miss, sorry, I lagged out. So
Dana.
can you say that again?
Okay, Dana, can you see my screen?
Yes, I can see it.
Okay, I want you please to plot the following data. Plot V versus T and find the slope. Do you know how to do it?
Yes.
Okay, try. This is a trial for everyone. It's like a warm-up activity before I give you the lab report to submit. ريم ويارا اثنيناتكم مقصصين، ما تسألوني ليش، بتعرفوا ليش. You're very loud. I have a class.
Until you're talking to us?
No, I was talking to Reem to be quiet.
Okay.
Because she's very loud. I suppose you're doing the graph. So it takes time to type. By the way, X is gonna be my time and V is gonna be my Y axis. This is very important. On Excel, it's very important to show the X first, then the Y. I select the whole thing and I click Insert, Scatter. Okay. While you do the work, I'm gonna have some fun and maybe color my graph. I want to make it blue. I want to add a title. You don't have to do this today, but you have to learn eventually how to do it. The title is Plot of V versus T. Also, I want to add the axis. I'm still waiting for you to show me the answer in the chat privately. If you know the answer for the slope. I don't want blue. I want to change the chart to another color. I just found some cute colors. I'm just okay, can I do this? How can I try and change the colors? Okay, green is nice. I know it's ugly. I'm just showing you that we can. Yes. Okay. So chart design. Your Excel may be a little bit different than mine. Vertical, I'm gonna call the vertical axis V meter per second. And okay. All right, I'm done with the plot. I'm sorry for this. I should delete it. What's that, by the way? In this experiment, we will explain capacitance and dielectric constant. What equipment do you see on the desk? Okay, wait. You have a capacitance box. That's old. I'm sorry for this disruption. Okay, back to Excel. You guys, did you finish?
Miss, can you tell me how to turn it into a graph again?
All right, so you have the x-axis, you have the x and y displayed as such. You simply select the values only and then click insert and you pick the scatter, this one. Okay, and you will automatically have the chart. You can learn later how to add a title and label your axis, but it's very important to learn how to add a title and how to label the axis. So please let me know if you're having difficulty finding, drawing the graph. Who finished question number 1? And 5, list the sources of errors. Okay, I'm just giving you extra questions because I believe it's a very important warm-up for us. So you leave me at least very confident with your lab report, with your new lab. So how's it going? Are we done with item 1? Just say yes in the chat or anywhere that we're done with item 1.
Yes.
Done with item
Professor?
1. Yeah.
Professor?
Yeah, just call me Jesse. Yes.
About the Excel,
Yeah.
I drew the graph correctly with slope.
Okay, let's do the slope. Let's do the slope together. I'm gonna right click. Okay, I'm gonna right click on the values, right click, add trend line. And you will have something on the right side of your Excel, something that says linear. I'm gonna click display equation and display R squared value. You will see that here you will have an equation. I will take this equation and I'm gonna make it bigger for everybody to be able to see it because it's not visible, and maybe change the color of it and make it even bold because I love, okay. So now this is the equation of my straight line. So let me repeat. I right click my points. Don't worry, Fadi, try again. This is only a warm-up. So I want you to learn how to do it with me because I know you have difficulty on this level. So I'm gonna right-click on the points, add trend line, and then add equation. So you can see that the slope is, can you read what the slope is?
9.448.
Miss.
Yes,
Sorry,
9.448. Yes, Dana, tell me.
Can you go back again to show me like how to make that line?
Yes.
What should I right click?
Yes, I'm gonna undo. Okay, so now that I have my points visible, I right click on one of those points. Do you know how to right click? Because on some laptops it could be tricky.
Yes.
Okay, right click, add trend line, and you will have something on your right, maybe options or something. Pick linear, display equation, display R. Does it show somewhere?
Miss, I'm for some reason not able to click on right click on any of the points.
Okay.
Like no, I mean like if I right click, it gives me alt text, format, cut, copy. Should I share screen?
Yes, why not?
All right.
I'm gonna stop sharing myself. Go ahead.
Is that visible?
Yes. Try
you still
to
see it?
Yeah, I see it. Try to right click on the points, not on the graph.
Oh.
Maybe
you mean like one of these?
No, on the chart.
I can't. It makes it makes it the graph, you know, it's like a picture.
Yeah.
For some reason.
Try again. It's okay. We can. If you click format, it's gonna be for the graph, right?
Oh, format?
Try. What if?
Okay.
Okay, what does it give you? Let's wait and see. No, that's for the graph. Top. I want you to stop sharing. Anybody else who found the slope, can you share your screen to show us? Anyone else? Anyone else who found the slope? Carl. Okay, Carl, can you undo and do it again?
Yes, sure.
Dana, I will come back to you, okay? Undo.
Okay.
Yeah. By the way,
I've already choose the lines from here.
Don't do that. Use the scatter only because it makes a big difference. It shows you a curve, that's why. So if you do right click.
Right click.
Add trend line. So it's exactly like mine. Do you have a MacBook?
No, it's HP.
Okay. All right. So it's exactly the same thing. We have the same office. Some offices are a little bit different. So I think, Dana, for you to solve your problem, simply open a new file again and do it. Maybe you clicked on something and you're not being able to click on the points. So your problem will be solved once you click on the points, okay? But it shouldn't be a big issue. So can I assume everybody is being able except Dana? And don't worry, we can try again. Worst case, we can meet again alone. All right, but let's try to fix this issue this week as early as possible. So this is the slope. So somebody told me the slope is equal to 9.448. I need a unit. Who can tell me the unit for the slope?
Per second square.
It is, so
per second square.
Why? Can you tell me why? How do you know?
Per second over second.
Okay, so it has to be unit
because
of
the
y.
slope is the acceleration.
Exactly, over unit of x. So it's the unit of y over unit of x, which is meter per second, which is equal to meter per second to the power 2. Or you can simply say, we know that the slope is the acceleration. And in this case, what is the acceleration? Free fall. Aren't we doing free fall? So the acceleration
is equal to the gravity.
Yeah, that must be equal to gravity, if you want to call it. Okay, so this is what we just found, the slope. We can read it from the equation. It's bx plus a, so b is the slope. The y-intercept, I don't care about it. It could be your initial speed. You know, the picket fence went through the photo gate with a certain initial speed, or I don't know what it is. Yes. All right, so that's the slope, and the unit is meter per second squared. We're done with item 2, right? Let me color it in blue. Deduce the gravitational field strength. I'm gonna say that G is equal to 9.448 meter per second squared, and that's the measured value. Okay, I know that G is equal to 9.8 meter per second squared, being the theoretical value. All right, so now you know that you just measured, right, G, but the theoretical value is not 9.448. Can you compare these two? How do you compare two values, the measured and the theoretical? So I'm waiting for you. I'm gonna have, yes.
Professor.
Just call me Jessie Nadia.
Jessie.
Yes.
You have to calculate the percent G.
Okay, I'm gonna call it percentage difference. Okay,
To see if it's accurate or precise.
Okay, basically percentage difference will give you accuracy and not precision. Okay, so I'm gonna write percentage difference to be equal to, I'm gonna take the absolute value, or you know what, just ignore if the answer is negative. I'm gonna do theoretical value minus experimental value divided by the theoretical value. And when I finish, I want it to be a percentage, so I multiply by 100. Can you do the work for me, Nazir?
All right.
So every time they ask you to compare, you calculate the percentage difference. Yes, what's the answer? So I'm gonna do those two minus each other.
3.59, which is 3.6.
Did you multiply by 100?
Yes.
So it's a 3.6%?
Yeah, 3.6%.
Okay, 3.6% is the difference. You can say this is less than 5%, so it is accurate.
Accurate, right.
Yes. Let me try to merge this to be able to merge across. Okay, and let me try, because this is not visible. How do I wrap text? Was it wrap? No, let me try to make this bigger. Okay, now we can see it. All right, so every time they ask you to compare, you calculate the percentage difference. Now I need, am I going too fast? Maybe some students are still stuck with drawing the graph and finding the slope. Let me ask each one. Dana?
Miss, I'm with you.
Yeah, did you, are you being able to find the slope, or you're still stuck there?
Oh, I stopped trying because it's not going to work. So I just kept focusing on what we're doing.
Okay.
Yeah.
Fedi, where are you right now? If you want, you can type. But you have to fix your microphone. Use your phone, anything. So I'm waiting for feedback from Fedi. I want to see if you know how to plot and how to find the slope. This is important. Joseph, would you please speak up? Joseph, may I talk to you, please?
Professor?
Jesse, yes, Nazir.
I have something
yes.
important. Assignment, the lab report, can I send it by mail? It's not working. I don't know how to submit it with the...
Okay, I will try to fix this. I will show you how. And I know some students, like 10% of the students, are having this difficulty. Joseph is not speaking up. Carl?
Yes, everything is good. It's okay.
Okay, perfect. Leia, tell me about you, Leia. You're good?
Yes,
Okay.
yes.
Rima, did you plot and found the slope?
Everything is good.
Okay, awesome. Now I need anybody, before I discuss how we submit lab reports, I need anyone to help me list the sources of errors. You know, 3.6% difference is big. So definitely this is due to some errors in the experiment. And you saw me releasing the picket fence inside the photo gate. Do you think there are some errors that we neglected, or some errors that contributed into making my gravity different than the theoretical one? Can we list
Yes,
some
miss.
sources? Yes?
I can definitely list air resistance.
Yes.
But I do have questions about our apparatus. So like, the machine that we're using, what's it called?
Photogate with the picket fence. The photogate is the one where you have the beam inside, and the picket fence is the ruler with black strips. So yes,
Right.
my sensor is not super precise. All sensors, they have a limited precision, and this is reason number 2, like a source of error. So far you listed 2, the air resistance and the limited precision of your measuring tool. What else?
Jesse, I have a question about the beam.
Yes.
So what does the beam catch? The beam catches like how quickly it's scanning the ruler, and that's how.
Yes, basically the beam only records how long you are blocking it. So if I'm blocking the beam for 2 seconds, the data studio will register that I've been blocking the beam for 2 seconds. So I need something opaque, like black, or like my finger, or something, you know, that is not see-through, not transparent. So if I block the beam for 2 seconds and I type the thickness of my finger or this black strip, distance over time, it calculates the speed. So it cannot tell the speed directly. It's an indirect calculation. It can only measure the time through which you've been blocking the beam. It's a light beam, invisible light. I think it's Bluetooth or something like that.
So, Miss, I think I could say 2 things about that.
Yes.
So you know how computers have FPS, which is like frames per second.
Yes.
And the more frames per second you have, the more you're able to register what's going on in the game, kind of.
Yes.
Right?
Yes.
So I think we could consider the beam as if it's FPS.
Yes.
I would say because it's not a very accurate or precise tool, like you said, I would say like the FPS version of this machine is not very precise.
I love your analysis.
Thank you. And I also think since it's dependent on color, based on what we've seen in the video, I could definitely say that the color of the ruler is probably not ideal.
Yeah, maybe it's a little bit transparent. Maybe it's not perfectly opaque. I don't know. I would think also that I want to block the beam in such a way that the ruler is super perpendicular to the beam. And maybe, you know, the ruler was not super perpendicular. This also will modify the time taken through blocking the beam. Yes? Can you think of something else? Maybe gravity is not 9.81 in the lab. You know, I was in the lab. It's not close to the sea level. And, you know, gravity is affected by altitude, isn't it? So all these are reasons why my measured G is far from my theoretical G. Keep those in mind in case they ever ask you about list the sources of errors. I'm gonna take a screenshot of this one and include in my document, this being my document, and let me use this being my scratch paper, send it to you, but I will definitely send you a fresh document for you to fill in your values. Okay, meanwhile, I'm gonna answer Nazih's question, and maybe Joseph. Let me go to Blackboard. This is your Blackboard. You were supposed to go under Lab 1. And when you go under Lab 1, there's something called Submit Here. Okay? When you click Submit Here, you click Submit Here again. You can see the deadline. Why is it Monday at 2? Oh, this is not your class. This is your class. So, but it's the same thing. It has to say Monday at 5 because your deadline is always Monday at 5. So submit here. So Monday at 5. and you browse your computer and fetch your file. It should be a one file. So make sure all your lab report is under one file. And you simply click submit. There's a submit button at the bottom of your thing. Why, Nazih, this is not working for you? It's working for most of everyone. Nazih submitted the work, but maybe you only did browse but not submit. Can you try again? Maybe you did save. I don't know why Joseph.
Professor, I submitted it.
You did? Let me check again.
Doctor, I submitted it. I don't know what even happened. I saw that there are 2 points. Yeah, I didn't submit it when it showed up. بس ما بعرف.
Listen, you can easily submit again. By the way, I wrote that you can have an unlimited. Oh, listen, Nazih submitted, Joseph submitted. All right. I don't know if you updated or maybe I did not refresh my page. Anyway, I still have Fadi, and Fadi already told me that he will figure this out today. Okay. So I assume everybody has no problems. We're happy with that? Do you feel ready for lab number 2?
Yes.
Okay, one last question before you leave. Everybody in this room knows how to find average and RMS?
Hello, doctor. You can the calculator.
You can, yeah, we can do that on a calculator.
Hello, doctor. So I changed my laptop.
Yes.
I think it's working now.
Okay,
Don't
awesome.
problem with the other
Awesome,
one.
Fadi. Fadi, please let me assist you. Like if you have issues,
Okay.
I
Yeah,
have
of
to
course.
help you, okay? Just let me know.
Sure.
Like Dana now
Okay.
has a tiny issue and she's gonna solve it. If she's not being able to solve it, she will tell me, I'm sure, and I will help her. Fadi, focus on lab number 1 and try to finish it. Everyone else, I should send you the results. I mean by results, the table with values tonight, this evening. So tomorrow morning, you can start filling in your lab report and it's gonna be easy. All right?
This is for lab 2, doctor?
Yeah, that's lab 2 and it's due next Monday at 5.
It's graded. Doctor, are we allowed to use a graphic calculator?
Of course. By the way, what you need is, actually, you can use any platform you want. Graphical calculator, the regular Casio scientific calculator, or any platform on your computer. But concerning linear regression and stuff, you may need a scientific calculator for it. Like you cannot use an app that states it's a scientific calculator, you know? So play around with all the apps you have and all the devices you have, and let me know what you're using so I can allow everything in the midterm. Now, to answer your question, Carl, yes, lab 1 and lab 2 are graded. Lab 0 was not graded. So lab 1 and lab 2 and up to lab 10, they are all graded and the total is 50% of your grade, and that's a lot. Okay? But trust me, it's easy to get a good grade on a lab report. Are we going back to campus on October? Most probably yes. I'm still waiting to see more updates from the department. So as soon as I know, I will let you know, okay? But the department so far did not come up with a clear scenario, but we're trying to come up with something clear to you. Most probably it's gonna be optional. I don't know, but I will let you know as soon as I know.
Okay, doctor. So it's fine if we can't attend because the campus is, my campus is in Beirut, not Byblos, and I'm not in Lebanon right now.
Yes, Fadi. Listen, I will do anything to be able to assist your needs. I will let you know, okay?
Thank you.
All right.
Professor, I submitted the lab report. I submitted it.
Yes, it's clear that you did, Nazia.
It worked. Thank you.
Yeah, you can see my screen. Yellow means submitted. Okay, but like few minutes ago, it was not submitted. Maybe it was my Blackboard not refreshed. Okay, all right. I'm gonna leave you. I'm gonna stop recording. Yes, stay with me. Yes, tell me.